Today, for Let's Build a Tetris-Like, I'm going to be adding rotation. I've already done it, so I'm going to walk you through how I got there. This is the ultimate goal. All 7 tetrominos rotating 4 different positions, and this is what's ultimately going to control our auto rotation that I am planning for. I do love being able to fly around these things in 3D. There's something very cool about like being inside of a Tetris game. I don't know. It's a game I've been playing forever, but I've been having a good time building this. But all right, enough of that. Let's back out here, and we need to look at some code. We're still doing most of the work. Most of the heavy lifting is in the Tetromino base class here. If you remember, you may have noticed that in my eyepiece, I originally had the code in here to create the blocks on the child instance of the Tetromino, but that wasn't really necessary. I forgot to put in the call to the parent constructor. So now that puts the heavy lifting back up into Tetromino base. And, okay, well, the constructor runs no matter what, but the begin play is where I'm creating all of the blocks. I'm setting the orientation. I'm setting the positions for each of those. And then I set up the timer that you saw to make them rotate as they go along. I don't think I had this before. I created a rotate clockwise and rotate counterclockwise. I'm not sure I'm going to need both of these. It's mostly in case I add like traditional manual controls, which I probably will since I am going to release this on PC as well as like phones and stuff. So that's just kind of like proactive. Right now I'm only going to be using rotate clockwise because the AI is going to handle the rotation and it's only going to need to turn in one direction. In order to keep track of which orientation it's in, I don't want to be moving backwards and forward. I also set up this normalization, this normalized rotation subroutine. The idea here is there are only 4 different positions that any tetromino can be in. So all it's doing is it's checking the orientation. If it ends up greater than 3, it loops back around and sets the orientation back to 0. Same with the inverse. If it's below 0, it's going to loop back around and set the orientation to 3. So we won't be getting like invalid positions. Let me also think here. Okay, so I did set this as a uint 8. It's not a lot of space, but this just means that it's going to be 8 bits, I believe. I don't think it's bytes. Maybe it is bytes. I think it's 8-bit. Yeah, 8-bit. Yeah. So for a number that only goes to 4, I'm just looking to save a little bit of memory there. It's not really going to matter ultimately in a game this small, but little things like that can add up. So it's a good habit to be in to use the smallest data type possible. But other than that, okay, so here are the new functions. The children are going to have access to those. And then the F timer handle, which is what is actually being passed into the timer manager. From that point forward, all I had to do was I didn't even need to create overrides for any of that stuff since it's all going to be running anyway. The only thing I had to do was go into the actual C++ files themselves and set up the positions. So for the eyepiece, I had to overwrite the block positions that are set in the constructor on the Tetromino base, but only because the eyepiece is a special scenario. The rest of them will fit in a 3x3 grid, but the eyepiece does not. It had to have like 2 sets of 4 long. So I overrode those in the constructor here, and then I created the set block positions, which previously, these 4 lines were up here in begin play. It was just setting the blocks to the eye shape. But now there's going to be 2 different positions. And this is going to be the horizontal position. And this is going to be the vertical. Now, I had to handle 4 different cases for the orientation because all tetrominos are going to have 4, even if the tetramino specifically that you're in only has 2 positions for a rotation, like the eyepiece. The S and the Z are also similar in that regard. The O piece, I think, traditionally doesn't have any rotation, but I like to add it in because it allows for some extra special moves in Tetris. If you're familiar with the game, you'll know that there's something called a T-spin, and it's just some like special logic that only applies to the T piece due to the nature of how it rotates. I like to be able to have that for all the different pieces that I can, and having the O piece be able to just kind of nudge itself into a corner that looks like it might be blocked off from. That was kind of a design decision that I made to have that set up. But let's go through each of them. So we have I, J, L, O, S, T, and Z. All right, so that was the base. And then the T piece, as you saw. Now, let me grab here. I don't use this very often. Drawing panel. Draw. No? Oh, there it is. Turn on. Okay, hopefully this works. So we have a 3x3 grid, and these are all imaginary positions. So there's going to be one here for 0, 1, 2, 3, 4, 5. I'm doing this with a mouse, so it's a little difficult. 6, 7, and 8. All right, so for the T piece, the centerpiece is always going to be there. So number 4, you will see, is in every single position for all 4 orientations. So every time we rotate, we're going to be switching between 1, 4, 7 and 3 and 5, or 3, 4, 5, as you see here and here, and 7 and 1. So 1, 4, 7 right here, and 3 will be these. 1, 4, 7, 3, and that'll make the T. And then over here, we got 1, 4, 7, and 5, so 1, 4, 7, 5, T. And then so that's the idea here. And so that goes across all 7 of the tetrominos. Let's turn off this, clear that. All right, and then the Z piece and the S piece are both similar, but it's going to be 1, 2, 3, and 4, and 1, 4, 5, and 8. And it's switching 1. Oh yeah, this is something I should probably explain too. Since there are 4 positions, but a rotation is only going up by 1, I had to set these to evens and odds. So that as you rotate, it will alternate between these instead of rotating and then rotating but not appearing to move, as if I did like 0, 1, 2, 3, like so. So yeah, that's why these are broken up into evens and odds. It's because for ones that only have 2 positions, I still want them to alternate every time you rotate. But with the T piece, that's not an issue. It's going to go around clockwise every single time. So then J and L, it's all the same, just more the same. Now, this is the only special case that I did want to go over. So like I mentioned before, the O piece, traditionally, I think it just stays in the lower corner. There is no rotation. But the way I want it set up is that there'll be a block here, 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 and here. The middle piece will always be taken up, and then the 3 around it will shift. Now, what this allows us to do, say we have a block here, and then, how would this go? probably a block here, something like that. And then we have a set of 4. No, that's not right. It's so you have your 2 blocks here, there'll be an empty space here, and then this is a size of 4. I made that too big. This is 2. This is 2. These are 4. And then this area here is just 1 block wide. So what we're going to be able to do is have the square come down here. This piece will stay where it is. And then in the next movement, it will move 1 diagonally this way. And then these 3 blocks will automatically switch to fill in these 3 spaces. So I'm going to call that an O spin or something. I don't know, for lack of a better word. We'll call it the O spin. But it doesn't look like it'll be able to go in there. But if you have knowledge of the game mechanics, you'll know that it will be able to go in there. That'll be specific to my little game here. So let's turn off the controller. The last thing, the timer. Now, without going into too much detail, to set a timer, you need a timer handle. So we'll go over to the timer base, and all it is F timer handle and a name. That's all you need to do. And that is going to basically control like this timer from this point forward. So from now on, I can do things like timer dot invalidate, valid. There's different things that you can do on the timer handle after it's set up. But to initialize it and set it, you need to get the world timer manager, set the timer, pass in the timer handle, and then you need a world object, which I just passed in the tetramino, and then a pointer, or well, an address of operator of the subroutine that you're calling. So in this case, I want to rotate clockwise every half of a second, and I want it to go perpetually. That's pretty much all you really need to know. There's a bunch of overrides for, or overloads for set timer, but that's the one that I use, that I want to set it to loop equal to true, and I forget which one this ended up being. Yeah, the in out, yeah, this is the handle. Then the user class will be the object itself. The delegates. Yeah, I don't think I was using a delegate. But anyway, that's how you look at these. You hold in control, click on this, and it'll show you everything that you need to set the timer. And that's about it. I passed in the rotate clockwise. It has to be fully qualified, so a tetramino base or colon rotate clockwise, but then it'll call everything else. It'll increase the orientation by 1. It'll normalize the rotation if it goes out of bounds down here, and then it will set the block positions. In the future, we'll probably have to handle the collision detection somewhere in here, but I'll need to set up the is colliding methods. We'll get to that in a later video. But ultimately, what this all ends up looking like is, if this UI for recording would get out of my way before I get too long-winded, we'll take one last look at it, and then we'll call it a video. A lot of explanation for a fairly simple behavior, but it's gonna all come together. Oh, why are you crashing now? What did I do? Did I not build? Okay, that was my fault. I didn't realize I still had the editor open. I don't know if this is a bug or what, but I used to be able to just build in Visual Studio Code and then all my changes would show up in here. But now if I don't hit the live coding button, they won't work. But this is it. This is our beautiful rotation set on a timer function and all we wanted to cover. So I hope you enjoyed this video. I hope it is helping give a peek behind the curtains of game development. That's all I really intended with this channel, is just kind of like make it less scary for people to decide if they want to learn. And I hope you do. In any case, I hope you enjoyed this video, and I will see you in the next one.